Welcome to the night class. Today we're going to do some more verifying of trig identities. These are the suggestions they suggest trying first. We're going to do as many of these as we can. After, we're going to do a couple of examples and then as many on out of your book as time allows us to do. So, these again, key word here. Suggestions. Does that mean there's one specific way you have to do it? No. These are just suggestions of things you can do. Okay? Number one says transform the more complicated side of the equation into the simpler side. So first off, we're dealing with equations. That means there will be a what? Equal sign. There's going to be an equal sign. There's going to be a left side and a right side. Okay? So they're saying whichever side is more complicated, maybe you might want to work on that side. Okay? Number two, substitute one or more basic trigonometric identities to simplify expressions. That was last chapter. We just simplified the expressions. Okay? Number three, factor or multiply to simplify expressions. Did we factor anything a minute ago? Yeah, remember we took it out, did the greatest common factor? That's what it's talking about. Number four, multiply expressions by an expression equal to 1. That's like multiplying something by x over x. Okay? X over x equals 1, right? And then number five, express all trigonometric functions in terms of sine and cosine, which again, we have already been doing 2, 3, 4, and 5. Okay? The only difference now is, number one, they are equations. All right? So, our first example, whoa, it's doing this again. Why does it do this? Why is it's going the wrong way? There it goes. Okay. We're doing 5, 6, 7, and 8, and 9. We may skip some, but we'll see how fast they go. All right. So it says verify that each equation is an identity. So in other words, that's a fancy word for proof. Y'all do proofs in geometry? Okay, you had the 2 columns. So this is a type of proof. Okay.
That was like the last thing we did for
right before the pandemic hit. So this is a type of proof, but it's not a 2 column. It's not like you're going to do. Okay. So we're going to follow the suggestions. It said to work the more complicated side first. Okay. I want you to understand. They're not going to give you one that's not true, but you can't assume it's true. Okay? And what does that mean? Well, that means if you have to prove that it's true. If this said plus 1, it would be wrong for me to subtract 1 from both sides because now I'm assuming it's true. Okay? I'm assuming they're equal. I can't assume they're equal. I'm trying to prove that they're equal. Okay? So as long as you remember, I can only work one side at a time, okay? I have to do it independently from the other side, whatever I'm doing, okay? So we've already talked about it. Which one's the more complicated side?
Right side.
The right side. So I'm going to write it a little more where it looks normal. Okay, so I didn't change anything. I just made it look cotangent over cosecant, okay? It says I'm trying to get it to equal to cosine. So we're going to do the same thing. We're trying to simplify this right side, and hopefully it'll look like cosine x. As soon as they equal, we're done. Our problem's finished. Okay? So what can I do to make cotangent sine or cosine? What is it equal to?
Cosine over sine.
Cosine x over sine of x divided by, what is cosecant? Can I change it to sine or cosine?
It's 1 over sine.
It is 1 over sine. Okay? That is the top one we use number, 5 on your formula sheet? Mm-hmm. And the bottom one we use number 1 on your formula sheet. Okay? Again, formula sheet, you need to be very, very familiar with it. If not, memorize it. Okay? ACT, you need to have a lot of them memorized. Okay?
Are you going to let us use it on the test?
Yes, I've already said that.
Okay.
Okay? You can use it on your test, but just know it would be very, very beneficial to you not to have to use it. Okay? Like I said, this one, the reciprocal ones you should already know. Right? Because we've already been talking about reciprocal. What's the reciprocal of sine? Cosecant. So that just means sine equals 1 over cosine.
Okay.
You got me?
That's the
That's the first three on your formula
That's
sheet.
like the U out of X one. Right?
Correct.
Okay.
Yep. All right. From here, I just math. How do you divide by a fraction? Multiply by the reciprocal, so times sine of x over 1, times sine of x over 1. These cancel. Up here, the sine of x is cancel, and I'm left with cosine x. And as soon as I get the same thing on both sides, I'm finished. Okay?
Instead of writing sine of x over 1, couldn't you just write cosecant over x? I'm not cosecant over x, cosecant x. Wait, no, because cosecant x equals. Okay, yeah, sorry.
Okay?
Wait, wait. Can you hold it like that for a second?
Yeah, I'm trying it.
I'm sorry. Just for like 10 seconds.
You good? Okay. All right. Again, I'm going to write it where it kind of looks right to me. All right. Here. Do we really have a more complicated side? Not really. They're both about equally complicated. You follow me? But one of them already has cosine and sine with it, and the other one doesn't. So which side do you think I'm going to work with first?
10.
The left side. Okay? So I'm just going to change this to where it's sine and cosine stuff. So what can I change tangent x to?
Sine over cosine.
Sine x
What number
over
was that?
cosine x. That's number 4 on your formula sheet. Plus secant x is 1 over cosine. Everybody with me so far?
1 second.
You just write faster than us.
Hey, wait, can't you simplify that?
You can, because they have what?
Common denominator.
So that's just going to be 1 over sine x plus 1 over cosine. How do you divide by a fraction?
Multiply by its reciprocal.
So I flip it and multiply. These all cancel, right? And then I have 1 times cosine x over sine x plus 1. So I'm done.
So easy.
Again, you're just trying to get the same thing on both sides of the equals. As soon as you do, you're finished. Okay? You can work both sides if you need to. You just can't work them. You just can't move something from one side over to the other. Everybody good on 6?
Hold on.
All right.
It's really nice whenever you do like examples of it with how
Numbers.
we usually see it. That's like the only reason that I'm kind of comprehending it. I'm still really confused.
I'm like trying to get it, but like not.
It's okay. Like I said, everybody that's saying I'm really confused hasn't been here, so that's normal. Okay. We'll work on you. Everybody good on 6?
You do it, and I'm like, oh, okay, but like I'm already like stressing about doing it myself.
Okay, well don't, because we're going to do plenty together before you have to do it by yourself. Okay? All right? 7. Again, I'm just going to rewrite this where it looked 1 over cosecant theta plus cotangent theta. Okay. Which side looks more complex?
The one that you have to redo.
Wait, you have to do both.
You do.
I'm gonna say the 1 over cosecant thing.
Okay. You want to try that one first?
Because the other one's just subtraction.
Sounds good to me. So, let's see here. I'm just going to, our suggestion is change them to sine and cosine, right? So let's do it. What is cosecant?
Cosine over sine.
Try cosecant.
Sorry. 1 over sine.
1 over sine theta. Plus cotangent is, that's the one I think you were saying earlier.
Yeah,
Cosine over sine. Can I add those? Yeah. So that's 1 over 1 plus cosine theta over sine theta. And if I wanted to write that without the 1, what do I just need to do?
Multiply by what they need.
Multiply by the reciprocal, and since I'm multiplying it by 1, my answer is just the reciprocal. Is everybody understanding how I'm doing that?
Wait, what? Wait.
I'm going to flip this and multiply. I'll just show it. I was trying not to have to show it. I'm going to flip this and multiply.
Oh, because you're multiplied by 1, so it's going to be the same thing.
Right. And I do that, God bless you, on the top and the bottom.
Oh, I just didn't understand what you said.
Okay, so all this cancels, and I'm left with 1 times the reciprocal, which was sine theta over 1 plus cosine theta. Okay? Do we have what's on the left yet? No. But is there anything really more we can go on the right? No. So, like I told you, it's okay to do both. You just have to work them separately. So now I'm going to go see what can I do to the left. Okay? Can I change cosecant to sine?
Yes.
Yeah?
1 over sine.
1 over sine theta minus cotangent is
Cosine over sine. 1 over 10.
cosine over sine. All right. Can I subtract those? Common denominator, right?
You can.
I can. So 1 minus cosine theta over sine theta.
They're back.
They're close, aren't they?
Can you just like flip it?
I can't just flip it.
Can you multiply it like by?
But what can I do?
Cancel out the
Why are you talking like that?
Because
multiply by
You can
negative
cancel.
1.
I don't know, man. That's like the opposite.
Where is this sign?
Hey, can you multiply?
Where do I need it? So,
Multiply by
and again, it makes it really hard to teach because there's a bunch of different ways you could go here. This is just the path I'm taking. I need the sign on top. So I'm going to put it on top, but if I put one on top, I've also got to put another one where? On the bottom. So this will become sine theta times that over sine squared theta. Correct?
Hold on.
Because I multiplied the top by sine and I multiplied the bottom by sine.
Yeah.
Okay? And again, you're just trying to match up parts here is all you're doing. All right?
Oh, that's so irritating.
All right? So, what can I change sine squared to?
Maybe sure.
Excellent. You said plus. It's not plus. It's
1
minus.
minus cosine squared.
I can change it to 1 minus cosine squared theta. Sine squared theta plus cosine squared theta equals 1. Therefore, sine squared equals 1 minus cosine squared theta. All right?
You forgot one of your things.
Thank you. Okay, forgot my theta.
Doesn't the cosines cancel out?
Close. A lot. Okay, and this is why it's scary. A lot of times they cancel these out. You can't actually cancel them out without factoring. Okay? Because we're adding and subtracting here. Okay, we got to get it to where they're multiplying. So what would 1 minus cosine squared be factored? All right, let's try something like this. What's x squared minus 9 factored?
X minus 3x plus 3.
I can do that because I'm subtracting two perfect what? Two perfect squares. Are these two perfect squares? Yes.
It would be 1 plus cosine theta plus 1 minus. Not plus 1.
Literally one number up there other than 1.
Okay.
And squared.
Does everybody understand we're using this principle right here to factor this? Now that we're multiplying, what can I do with these 1 minus cosine thetas?
Cancel.
I can cancel them.
And then you
And
have.
then you have it.
And I'm left with sine theta over 1 plus cosine theta.
That was so complicated.
Okay, but I'm
seriously confused on who sits down and comes up with all of this.
People that like to think. I don't know.
Okay, so that's a lot.
They must have no life.
It's a lot. It's just a lot. You just gotta process it.
All right.
Like, who actually thought, you know what, let me point to something.
Let me put some signs in there and, you know, just.
Number 8, which side do you want to start with? Okay. So that's going to be sine theta. What can I change tangent to?
1 over sine. No,
Sine over cosine.
Sine over cosine.
the hopes of me actually learning this.
Does anything cancel there? Stay above the line.
No.
So sine times sine is?
Sine squared. At least I said slim. I didn't say not at all.
Sine squared theta over cosine equals.
All right.
What's the other side?
Can I change?
Completely honest. Already lost.
That can, what is that? Is,
I can change it, but I don't know if I need to yet. He said I can change the sine squared theta. We've already done it once. I can change it to 1 minus cosine squared theta. Okay. But let's wait and see if we need to. Okay. We might not have to. All right. Let's go over here to the other side and work it for a little bit. What does secant? What can I change it to?
1 over cosine.
It is the reciprocal of cosine, so it's 1 over cosine minus cosine. In order to add or subtract fractions, I need a common denominator. So that if I make a cosine theta on the bottom, I need to put another one where? On the top, which makes it cosine squared. And now, what is 1 minus cosine squared? Equal to sine squared theta over cosine theta. Same thing. Okay? Some you can do in 2 steps, some it takes 45.
Like number 7.
All right?
What is number 9?
What is number 9? Number 9 is not bad if you've seen it before.
Well, I've never seen
And I'll be honest, a lot of this is seeing them before. I realize some of you haven't seen these before. So, just to show you how quick and easy this is, you've already done it. You simplified this in your homework that we just finished going over, okay? I'm going to multiply this out. Remember the shortcut. Sine squared A, negative cosine A times negative cosine A would be positive cosine squared A. And then what goes in the middle? You multiply them together times what? Times 2. So sine times negative cosine times 2 would be negative 2 sine A cosine A. Okay? Everybody with me to there so far?
Wait, why was it a negative? Oh, because it's a rule that if there's a negative right there, then there's going to be a negative.
Correct. All right? And that's plus, isn't it? Thank you. Now, what is sine squared A plus cosine squared A? 1. So I'm left with 1 minus 2 sine A cosine A.
Is that all we can do for that side?
That is pretty much all we can do on that side. All right? So let's look at the left. What is different? There's a little 2 and there's a cotangent. Everything else we're good. We got the 1 minus 2. See, we're on the right track.
Can't you just do this?
No. So this is going to be 1 minus 2 sine squared A. Cotangent of A can be written as cosine A over sine A. And now, this sine and this sine squared do what? Cancel. So I'm left with 1 minus 2 sine A cosine A. Same thing, because those cancel. Okay? Everybody good? That's
Wait, I think that's. I wouldn't say.
don't say it. All right. Let's try some off of your actual homework. So this is, if you want to try it on your own, you can stop the video. If you want to keep going, I'm going to let it keep rolling. And we're going to do some from the book. So let's try some here. Let's see here. You got 13 through 27 odd on page 434. Says tangent of A equals secant A divided by cosecant of A.
Okay, 1 second.
I am 1 second.
I don't know. My binder is trying to make me stop. It's stuck.
I will ask questions and let you tell me what to do. Which side are we working? The right side. I would agree. We might work the left eventually, but I'm starting with the right. What am I going to do to the right side to work it?
Change it to sine and cosine.
Change it to sine and cosine. So secant is
1 over cosine.
1 over cosine A divided by cosecant is
1 over sine.
1 over sine A. How do you divide by a fraction? Flip it and multiply, right? These all cancel on the bottom. I'm left with sine A over cosine A, which is tangent of A. Now, the more you do these, you'll get quicker at them. You see all this work I wrote here? Okay? Eventually, you will realize that, hey, if I have secant on top, I can just put what on bottom? Cosine. Why can I just put it on the bottom? Because they are what? Reciprocals. Same thing with the cosecant. If a cosecant's on the bottom, I can just put what on top? Sine, because they're reciprocals. And if you know that, you can skip all of that.
That's what I was thinking.
Okay?
I said that
I'm showing people that so they know why you can do that.
I was
Thank you
thinking
for
that. I
showing
was
me.
like
Okay.
thinking about the formulas, and I was like,
Yes.
literally the same
Yes,
thing.
yes, yes.
I was just
Okay?
thinking of
I
the same
want
thing.
you to be able to skip this, but I don't want you just to skip it just because, well, my teacher said I could. I want you to understand why you can skip it. Okay? But yes, you can skip all of this. Just know anytime you're doing a reciprocal, you can just, if it's on the bottom, you can put the reciprocal on top and it's the same thing. Okay? If it's on top, you can do the reciprocal on the bottom and it's the same thing. Okay? Everybody good on 13?
Yes, sir.
Moving on. 15. All right, just go to the next page.
Why is your board lagging so much?
I don't know. It's just an old board, I
You
guess.
still rolling with the camera? I mean, the record cosine?
I am. I figure somebody might need this
Yes, sir.
out there in internet land. Okay. Give you a few seconds to write it down. what side do you think I'm going to try? The left. But the right looks a little more complicated. But what does the right already have? That's right, sine and cosine. It's already sine and cosine. So it's kind of like it is what it is, okay? So I'm going to try the left side, okay? What do I change secant to?
1 over cosine.
1 over cosine, the reciprocal. 1 over cosine x. Tangent x. Its reciprocal is 1 over cotangent, but I don't want to put that.
This one's easy.
I want it sine and cosine, right? So that would be
And then you just subtract.
sine x over cosine x. They have common denominators, so you can write it as one fraction.
And that's it.
And that is it. As soon as you get the same thing on both sides, you are done. I hear a lot of surprise, like I'm not picking on my man Hayes here, but and he's not the only one I've heard do it. Oh, I didn't even realize it's the same thing. Always have your mind focused on what you're trying to get. Okay? All right? Always, don't ever be surprised when you're like, oh, they're the same. Okay? That's what you need to be focused on. What can I do to make it the same? So that's kind of, you're not working the right side, but you're using it to try to, hey, I need to figure out how can I get 1 minus sine x on top.
Yes, sir.
Okay? So when you do that, don't be surprised. Be like, oh, okay, I'm on the right track.
I was a little
All right.
surprised.
I know. I can tell it in your voice.
I'm like, oh.
You're like, oh, there it is. It's like walking in the woods and you just stumble upon what you're trying to find. Oh, there it is. You know, I wasn't really looking for it, but
But I found
there it is. Okay. I want you to be looking for it. Oh, hush.
Me neither.
17. 17. Secant of x. Cosecant of x. So times there equals tan x plus cotangent x. All right.
Right.
Left, right, right. Doesn't matter really.
Aren't we gonna have to do a little bit of work on
We're
both
probably gonna
sides?
have to work a little bit on both of them. Okay.
Well, let's just start on this side.
Just start on the
Make it
left.
easier to
All right.
write.
So this would be 1 over cosine, right? And 1 over sine. So we just got 1 over cosine x sine x. That was quick and painless. Okay? On the right side, sorry about that. Sine over cosine x plus cosine x over sine x, right? Cotangent is cosine over sine, tangent is sine over cosine. If I just do math, can I add those? No, so again, we're going to do our little trick here. Combine the bottom two, right? That will make cosine x sine x. Yes? Right? I take whatever's on the bottom over here, multiply it by the one that's on top over there. Same thing on the other side. So I have sine squared x plus cosine squared x. What is sine squared x plus cosine squared x? The answer is the work. Okay? There's no, because you already know the answer. Okay? They're giving you the whole, like, that's the answer. The problem is the answer. You've got to show me how do you get them both the same thing on both sides. Okay? Everybody good? Ready for 19? I think we got time for one more. We'll let this one be the last one. Hopefully it won't be too bad. Whoa! That did not turn out like I wanted it to. And again, Candy, being that the work is your answer, it makes it a little harder to grade because not every problem is done the same way. So you might do it one way, and Chloe might do it a different way, but y'all are both doing it right. So You both get it right.
Gotcha.
Chloe seems to be a little not sure of herself.
Well, I'm gonna go home and learn it.
Oh, okay.
That's my plan too.
All right.
No, I'm not learning this stuff until the next.
Which side do you want to work?
Right.
The right. I can buy that. I know we're supposed to change things to sine and cosine, but before we do that, I'm just going to divide. Okay? I'm dividing both of these things up top by secant A, cosecant A. So I can write 2 over secant A, cosecant A, plus, what's secant A, cosecant A over secant A, cosecant A? Plus 1. Does everybody understand what I just did?
Hold on.
Yeah, sure.
It's
Let me-
basically just.
Let me show you how I did it
Okay, hold on.
Yeah.
Give me,
numbers.
wait, give me 1 second.
Okay?
Okay, so you got 2 over secant A plus cosecant A.
If I divided 2 plus 4x by 2,
It would be 1 plus 4. No, 1 plus 2.
I divided 2 by 2 and got 1.
Oh, so
4x divided by 2 is 2x.
So
I'm
you
doing
did-
the same thing here. I'm saying
2 over
2 over
and
that equals this,
and then secant A.
and then that over that is plus 1.
That's pretty easy.
Okay?
I get it now.
Now I can change this to sine and cosine. Again, I'm going to do my little shortcut. I'm just going to move the reciprocals where? To the top. So what's the reciprocal of secant A? Cosine. So I'm just going to put cosine A on top and put reciprocal of cosecant is sine A on top. So this is 2 cosine A sine A plus 1. We got about a minute. On this side, multiply it out. Sine squared A plus 2 sine A cosine A plus cosine squared A. Hey, just to show y'all, what's sine squared plus cosine squared? 1. Y'all have a great day.
Have a good one, Coach.
Don't forget to study for your test and don't forget to stay above the line.